Test. All right, I'm gonna do about 45 minutes, and I'm gonna try and hit it hard. Really pay attention here. Really drive it through. Yesterday was going a lot more slow. I think sometimes it helps to go through things like deep read them very slowly. Fine tooth comb, and just let them germinate overnight. And other times it's best to switch it up and just kind of like hit it a little faster. Okay, so chapter 9 is on classes. A class is basically a category. It's just a category of something, anything. It could be people, cars, guitars, dogs, um, students, bands, right? Countries, any category, right? So, all right, over here, we're going to create individual objects from the class. So you create the class is like the template for the category. And then from the template, you can create individual instances. So for example, you have a class called country, and then that class has certain default, um, let's say, attributes or behaviors. So for example, a country has information like population, right? Or I don't know, um, weather, right? And a country can perform certain actions uh, like steal taxes. Well, steal taxes, that's a redundancy, or wage war, right? Or oppress the populace, whatever it is they do. So when you create an object from a particular class, this is called instantiation, which sounds like, you know, like you're around a Ouija board, conjuring something. So instantiation, when you do that, you create an object from the class, which we call an instance, right? So the instance of a class is an object. In other words, you have a class called dog. So you create a dog called, Fido. And Fido, this object, is an instance of the class dog. Okay, so it tells us here that this is very important. It's going to change the way we see the world, how we organize things. It's going to help us collaborating with other people. It's just going to help us with everything. Okay, so creating and using a class. You can model almost anything using classes, which is true. If you think about it, any noun that you can think of, right, has certain properties and actions. And you can model these if you assume that you could sit here and write all of them out. Um, some things like a rock maybe doesn't have actions. I mean, a rock, it could perform the action of falling on your head, but then again, somebody would have to drop it. It would have to somehow be dropped because a rock will not fall on your head of its own volition. But a rock certainly has properties like, weight, texture, material, whatever, right? Age. But the point is that you can model anything. You can model obviously people, right? But of course, modeling a human and all of their things that they could potentially do and their behavior would be like insanely huge. But that's why it's called a model and not an exact copy or a clone, right? Because you could model things like, person, and you can model things like laughs or eats or runs, right? Whatever was relevant to us. So we're going to create a class. It's called dog. Now here's where the conceptual stuff ends, and we start actually doing stuff. So I'm just going to recode this. So I'm just going to type it out exactly as the book has it here. And okay, so we got a class dog, right? This is how you start the thing, right? We can do a doc type, uh, simple dog model, and now I'm gonna explain this the way that I've understood it so far. So you always start with this function, and you have this in it, which is a dunder method. Dunder meaning double underscore, and I believe this is there. So like it won't like get confused with functions that you made up because this is something that's like already part of Python or something like that. And then it has to take at least one parameter called self. And this self thing seems abstract or like almost philosophical or something at first, but actually all it means is that when I create an instance from this class, in other words, if I have a dog called Fido, right, and the way that I would create this dog is like I would simply say dog, capital D, right? Like over here, you see the colors are the same. I need a better. I can't talk, bro. I need a better color scheme. But anyway, once you do that, and you go in here, I guess technically I don't have to put anything in here, right? But self passes the object dog. So self is just the thing you just created. So in this case, self is Fido. I think, all right, don't freaking quote me on it. I'm just going to speak it out the way I understand it. Then I'm going to go back and review and see, if I got it right and kind of self-correct. Okay. All right. So obviously, this is not a tutorial, right? It's not one of these like the last Python tutorial you'll ever need on classes. Um, it's just a guy figuring it out. We in hustle mode, baby. Okay. So now for the dog, we want to give it certain attributes or stuff. So let's go here. So we give it a name and age, name age. That means when you create the dog, right, you will give it like a name and you will give it like an age, right? And we could call the dog Fido, let's call it my dog, okay? So you give it a name and age like this, right? And again, self is like the object that you're creating, if I understand it correctly. Now, inside here, right, you're gonna take self, which is Fido, the thing we created, and you're gonna say that self you're going to use dot notation, has an attribute called name equal to name, and then self age equals age. And I don't totally get this right now, like why this is necessary, but we're going to figure it out in a second, okay? Yeah, and we could just stop here. In the meantime, though, if you want to add actions, you just add them as additional functions. So you have an action for sit, and sit is going to take self, right? So like my dog, right, is an instance of the dog class. The dog class has an inbuilt behavior or function called sit. So it's kind of like when we use the function sit in that class, the function has to take something. It takes self, which is what? My dog or Fido, what we just made. Okay, that's why you need the self there. So um, for now, let's just say, print and you say Fido is sitting. So this here name was what we passed it, Fido, right? This here name is what we passed it. The parameter took the argument Fido. This parameter took this string. Yeah, I'm saying this for myself to really like drive it through. The parameter took this string. Now, we took this parameter and we said this parameter is going to equal in this particular um, instances name will be the parameter we passed, will be the argument we passed to the parameter name. So if I want to say name is doing something, right? I'm going to say self name is now sitting. Now, what I would like to know is like, this is a function, right? So it's like, wouldn't these variables only be available inside this function? Yet this separate function can see self-name, maybe because it's a class. So it's an exception. That's something we can find out in a second. So for now, like if I call this function, this thing is just gonna print something, right? But like, this is very basic stuff. We're just hard coding one single, response. Um, and then we have like rollover, right? And same thing. So we say print Fido rollover or whatever. So self name, right, is rolling over. All right, great. And now, right, um, if I say, if I do this, right? So if I do this, I get the dog's name, right? If I do this, I'm going to get the dog's age, right? And if I want to get these the functions, then I say I call these methods on the dog. So sit, and that's it. Okay, Fido is now sitting, and again, if I go here and I say roll over, right? Fido's rolling over. So again, going back to this self thing. So basically, when you say my dog and you call this function sit on the method, you call this method sit on the dog, there's an argument in here, even though we don't have to write it. And that argument is my dog. Okay. So this is sit, my dog. It passes my dog here. Okay. Let's read, let's go over the explanation now. And then I got some things that I want to ask. Got to ask my GPTs. So there's a lot to notice here, but don't worry. Huh. So we defined a class by dog, that's line 1. All right, capital name, there's no parentheses. There's no in the class definition because we're creating this class from scratch. So he's saying there's no parentheses here because you do that when like something already exists, right? So we're creating this from scratch. So the init, it's a method init. So this is a function that's part of a function that's part of a class is a method. All right, we know that everything you learn about functions applies to methods. The only practical difference for now is the way we call them. So the init method he has on line 2. Oh, like he numbered it to, right? So the init method is a special method that Python runs automatically whenever we create a new instance based on the dog class. So whenever you create a new instance, this method init runs automatically. This method has 2 leading underscores. That's why it's called a dunder method that prevents Python's default method names from conflicting with yours. Make sure to use 2 underscores. Okay. We define it to have 3 parameters, self, name, and age. The self parameter is required in the method definition, and it has to come first. You got to include it because when Python calls this method later to create an instance of dog, the method call will automatically pass the self argument. Every method call associated with an instance automatically passes self, which is a reference to the instance itself. So like I said, if you say my dog here, right, and you point that to, you use the instance, right, this is being passed to the init function. So Fido goes to name, this goes to age, and what goes to self? Like, I think this. I don't know technically if that's correct, but whatever you just created goes here. Now, the 2 variables defined in the body of the init method each have the prefix self. Over here, right? Name and age, self-name, self.name, self.age. Any variable prefixed with self is available to every method in the class. Okay. So this is how like this function here can see self.name, because any variable prefixed with self is available to every method inside this class. So if I said the dog's name is Fido, I put it, that's my argument that, I give to this parameter name. Then I say this parameter name, right, is now inside this function, this entire class, rather, be accessible by self.name. So every function in this class dog can access self.name, which is what we gave it. This line self.name equals name takes the value associated with the parameter name and assigns it to the variable name, which is then attached to the instance being created. Variables that are accessible through now, variables that are accessible through instances like this are called attributes. The dog class has two other methods defined, sit and roll over. Because these methods don't need additional information to run, we just define them to have one parameter, self. The instances we create later will have access to these methods. In other words, they'll be able to sit and roll over. For now, sit and roll over don't do much. They just print a message. But later, they could do a lot of other stuff. All right, making an instance from a class. Think of a class as a set of instructions for how to make an instance. So class is like a category that has a set of instructions for how to make something. The dog class is a set of instructions that tells Python how to make individual instances representing specific dogs. So if we make a dog, we say my dog equals dog. We pass it Willie and 6, which is name and age. And then if we print my dog's name as my dog.name, right? Which in this case, the my dog is equal to self, right? I'm going to get the dog name. The dog class we're using here is the one we just wrote in the previous example, and we tell Python create a dog whose name is Willie and whose age is 6. The init method creates an instance representing this particular dog and sets the name and age attributes using the values we provided. Python then returns an instance representing this dog. We assign that instance, creates an instance representing the particular dog, and sets the name and age attributes using the values we provided. Python then returns an instance representing this dog. We assign that instance to the variable my dog. The naming convention is helpful. We can usually assume, all right. To access the attributes, so like the name or the age in this case, you use dot notation. So if you do my dog.name, you get that dog's name. So this is how Python finds an attribute's value. Here, Python looks at the instance my dog and then finds the attribute name associated with my dog. This is the same attribute referred to as self.name in the class dog, which is in here. We use the same approach to work with the attribute age. All right, now the methods like sit and roll over. After we create an instance from the class dog, we can use dot notation to call any method defined in dog. So if we made the dog sit and roll over, we say my dog.sit, right? And you call that method. It's a method, so you need the parentheses, right? And you want to call separated by dot. And when Python reads my dog.sit, it looks for the method sit in a class dog and runs that code. Python interprets the line my dog roll over in the same way. Syntax is useful when attributes and methods have been given appropriately descriptive names. We can easily infer what a block of code can do. We can make as many as we want, right? Here we'll make another one called Lucy. Even if we use the same name and age for the second dog, Python will still create a separate instance from the dog class. You can make as many instances from one class as you need, as long as you give each instance a unique variable name, or it occupies a unique spot, or it occupies a unique spot. So we could have another instance called we could have another instance like your dog that is also named Willie and also has the same age, and it would still be a separate instance. So like over here, if I just print my dog, right, then you see that this is an object, right? And this is, I believe, its location in memory. Now, if I went here and I said my dog 2 with the same exact attributes, right? You see it occupies a different place in memory, which makes sense, right? Like two people could have the same name, for example, right? What if we did this? Create it twice. It is only created once. Okay, these I already did yesterday, so I don't know if I want to redo them. This was the restaurant. Make a class called the restaurant. The init function stores two attributes, name and cuisine type. Make a method called describe restaurant that prints these two pieces of information. So the restaurant's name is, and a method called open restaurant that prints a message indicating that the restaurant is open. And then make an instance called restaurant from the class. I called it my restaurant. Print the two attributes individually. So that will be my restaurant dot name and my restaurant dot cuisine type. And then call both methods. Which was it? Seb's Kitchen, Cajun. Okay, I don't know why I said Cajun, but whatever. Second exercise said start with your class from exercise 9.1. Create three different instances and call describe restaurant for each instance. So here's restaurant 1, 2, and 3. And right, and then the third one was make a class called user, create two attributes, first name, last name, and then create several others that are typically stored in a user profile. I said location, age, couldn't think of anything else. Make a method called describe. So first of all, in init, right? We take these parameters. We take you know like the arguments we're going to pass to them, and we set them equal to self dot first name, so that every other function in here will be able to access these. Okay, so self dot first name, self dot is how we would access them. All right, that are typically stored in a user profile. Make a method called describe user that prints a summary of the user's info. So here are first name, last names, details. And then what I did was, instead of printing each one individually, like print this, print that, right? I said for value in self.dict. So why did I do that? Because because this Dunder method here gives you a dictionary of these things and their values. So for example, if I printed user1, wait, is this going to work? Okay, there it is. See, so if you take this this instance and use dot notation to call dict, the dict method, which is inbuilt in the function, you're going to get a dictionary of the parameters and each, where each argument you pass is the key, and each key has the value that you passed to it, right? Where each parameter is the key, and each key's value is the argument you passed to the parameter. So since this is a dictionary that contains all this stuff, I said for value in self.dict, and then I extracted only the values like John Doe LA27, and then I printed them instead of going print, doing this, right? And then doing this one by one, like users first name is, self first name or whatevs, right? So now if I did user1, so now if we do user1, describe user, right? Here are John's details. User's first name is, oh, never finished this, right? Self-touch. So I'm saying instead of writing out, print, user's first name is self.first name, user's last name is self.last name. So instead of that, I just looped through the dictionary. All right, make another method called greet user that prints a personalized greeting. So hey, self first name, how you doing? How you doing? Anybody see Norbit? How you doing? All right. I watched it the other day. I was like, I didn't think it was gonna be that funny. I was like, okay, so Eddie Murphy in a fat suit doing stupid crap, but man, the story was good. The writing was good, and like he won you over with those characters, man. Hilarious movie. All right, not Eddie Murphy's best, right, by any stretch, but definitely a good secondary watch. Um, and that's it. So so this stuff's done, right? And then making the prints a personalized greeting. So done with these exercises, and then working with classes and instances. Now, before going to this, I'm going to take like 15, 20 minutes on this stream, and I want to go over some of the things that I generated yesterday with the GPTs. I think it was two messages. Right. So let's go through this together. I think it's important that, like ChatGPT itself um, can be a rabbit hole and like a huge time suck if you don't use it wisely. Because you know what I'm talking about. You go there and you ask something, you're like, oh, this is going to help me clear it up and I'm going to learn so much faster. And then it spits out a whole bunch of crap. And yeah, I know you could say be succinct and be more detailed with it, right? Give it a role and all of that. You are the world's best programming teacher. But it gives you stuff that leads you to asking additional questions, and then the next thing you know, you're off looking something up, to understand this better, and wasting your time. So it's very important that you leverage the tool itself because otherwise it could also kind of start sucking up your time. Anyway, so yesterday I asked it, starting chapter 9, I want the highest leverage, broad overview concept. Like, what is the one thing you need to understand? Like that 80/20 of it, right? So, highest leverage concept is this: a class lets you create your own type of thing. Okay, we know that. So, up until now, we've been using Python's built in types, right? Strings, integers, lists, dictionaries. These are classes that have their own, thing inside. So, now, chapter 9 teaches you how to say, I want a new kind of thing that represents something in my problem domain. And once you've defined the type, you can make individual examples of it. All right, super basic. We get that. Think of it like this: class is a blueprint, an object, or an instance is one actual thing created from the blueprint. Now, here's the thing: objects have state, things they know about themselves. Our car knows its color, mileage, a client lead knows stuff, and objects have behavior. Car can drive, client lead can add notes. So you shift from I have a bunch of variables to I have a thing. So before classes, right, you'd be like client name, client budget. After classes, just client, because these things are part of client. It's basically, you could almost think of it like a folder where you put similar things inside and then you pick them from that folder instead of having a bunch of files scattered all over your computer. So when you're coding something, right, instead of saying, what variables do I need, right, you start saying, like, what are the things in this problem? I can create a class of this and then put everything in there and then access it like that. So when you encounter a problem, look for nouns: student, book, order, invoice, customer, workout, appointment. All right. Then I got a little deeper. If a method is a function attached to a class, then what is in it attached to? If a method is a function, Steph, what you saying? If a method is a function attached to a class, then what is in it attached to? Because in it itself is a method. So it is also a method attached to the class. It's just a very special method the Python automatically calls right after an object is created. Think of the process in two separate steps. Create an empty object, initialize that object with data. So init handles step two. So init gives it data. So when you do my dog equals dog Fido, Python says create a new dog object, my dog, and then put stuff in it. And it is attached to the class. So it gets called when you write my dog.bark the moment it comes into existence. Okay, so it gives it like its default stuff. Python actually calls another method called new to create the empty object first, and then it initializes it. But we can ignore that for now, it says. So it's class definition, create an object, Python runs in it, object is ready to use. Then I said, what is self? Self is a specific object that the method is currently working on. So if you have a dog, Fido, then here, when you do something with dog one, self will be dog one or Fido. So if you do dog one dot bark, here we have bark self, right? Then you have the dog here that's being passed directly. So self is just the thing that you are actually, you know, doing. All right, easy enough actually. I think that's pretty sensible. One more thing that confuses everyone. Def bark self, but you called right. So the function, the method inside the class has self, but of course when we call, the bark method, we don't need to put dog in there, but actually that is what's happening. Yeah, okay, easy enough because it's built in. It's built into the function. The It's built into the class. The class already has self. That is the object that you call in the method on. In other words, if you do dog and you call the bark method on it, which is already part of the class, you're already passing dog to it, just like here. Access the data belonging to this object. So self.budget means the budget stored inside this object. Self.addNode means ask this object to run one of its own methods. So class blueprint, object is the actual thing created, and self is the particular object. And then I was asking about looping through them for the exercise. So that's good for now. Short, but I think it was highly focused and active instead of, slower, like ingesting kind of thing where I just read everything very slowly and I stare at it. Yeah, and going to continue later with the rest of this chapter. I remember this stuff from JavaScript, man. And yeah, I mean, classes, it's like you want to create something that is like a bunch of students, right? Uh, like a automatic grading system. So now instead of sitting here saying student, you create a variable called student grade. Then you have a variable called student class, right? Instead of doing all of that nonsense and like holding students, for example, in a list or a dictionary, you create a class, and that class already has like student things like student attributes like student name, class, age, units, blah blah blah, and then you can just grab those anytime you need them to start building stuff like units completed or late assignments or whatever else. So yeah, happy with this one. See you next time.